Okay, so now let's try another machine learning method. So we're going to go into our artificial intelligence toolbox. This time we're going to go to volumetric classification and self-organizing maps. And so with self-organizing maps, what we have to do first is we have to select the attributes that we want to run. So again, I'll pick some of my favorites from energy ratio similarity. I'm not going to pick quite as many this time. I'll pick GLCM energy. I'll pick, let's see, what's another good one? I'll do GLCM entropy. I'll go in and I will pick now, let me move over here, my peak frequency, if I can find it, my peak frequency. Next up, my peak magnitude. And then I'll pick out some of the spectral ones, which should be closer to the end. So I'll pick out spectral bandwidth, and I'll just go for the whole list. Spectral roughness and spectral slope will be the last one that I choose here. Okay, I've got all those selected, and I'm picking out 8 attributes. I want 256 classes. I'm going to decimate everything by 5s, and I'm not going to put in any supervision this turn, so I will click execute SOM 3D. So that took about 20 minutes on my computer, and we can see that it has finished running, so we will execute out of the SOM. And so now that the SOM is finished, what we have to do next is we need to plot it. And so, at least in AASPI, what we want to do is we want to go to our visualization display tools, and we are going to do a cross plot. So in this case, what we have is our input X attribute. This one is going to be SOM axis 1. So we have to go through here. I'm going to find SOM projection axis 1. And over here we will have SOM projection axis number 2. SOM projection axis 2. Okay, so I'll have these two cross-plotted against each other. Let me think if there's anything else I want to change. We're going to set the clipped voxels to be white. And yeah, let's execute the crossplot. And I'm just giving it a few minutes to run. Okay, and so you can see a couple plots show up. We've got our, let's start over here. So we've got a couple of different color legends. So here's our full color legend. Didn't mean to make it that big. But this is the two-dimensional color legend that we are using for our SOM analysis. We also have our co-rendered 2D color legend and histogram, and our 2D histogram. So you can see with all these plots, this is why I tend to work on 2 screens. Alright, so our histogram shows us how many hit points, roughly are in each area. So we can tell here that we have a lot more of these blues and greens that will be showing up in our SOM results when I show those in a second. And then we aren't really using the area that's black. Those aren't, that's not part of the two-dimensional space that's being clustered. So this might make more sense if I show it to you in the seismic data kind of realm. So here is our SOM results. So we're kind of moving down through the data, looking at a map view, and we can see the different clusters. You'll notice, like I mentioned before, we have a lot more in those kind of blue teal clusters. Here we're looking at some of the same depths that some of our other attributes have been in this kind of lecture series, and we could see some variations. Now, I want to just end this by kind of reminding that when we do unsupervised clustering, we still have to go in and give meaning to the clusters. So this would be our job as a geologist now, if we have well data that we can look at in comparison with our seismic, or we have other information, we could go in and give, maybe these yellow or golden colors are more of a sand facies.